Up till now, we have only seen single models. Now we will understand how to deal with assembly models. Whenever we are working with assemblies, we need to define the contacts between the two components or geometries. The advantage we have in Ansys Workbench mechanical window is that these assembly contacts are automatically defined. Wherever two bodies are in contact, a contact region is defined over there. So the user does not have to manually define the contacts. So this is one of the greatest advantages we have in Ansys Workbench. Now let us understand how these contacts are defined. We will open one assembly. Let us open one assembly in Ansys Workbench. I will import one assembly over here. And now we will enter into the mechanical window. Once we come to the mechanical window, you can see the assembly that has been imported. The assembly has all these parts over here, and the parts are renamed. If you see very carefully, the parts are renamed. Renaming the parts in the assembly is very important. Suppose if you import the assembly and the parts are not renamed, if you are getting it as part 1, part 2, part 3, part 4, please go to the geometry design modeler again. You can come to the design modeler and you can rename all these parts again. It is very important that you rename the parts, because when you open the contact regions will be defined according to the part name. If you see this image over here, okay, can you see the contact region which is defined is, you can see the contact body names over here. In this image you can see that the part name is caster axle and caster wheel. So if the names are written, it becomes very easy for the user to understand where exactly is the contact. So now in this assembly the parts are already renamed, and now if you see, you have one extra option over here that is called as connections. If we expand this connections option over here, you will have one more option inside that is called as contacts, and if you click on this, all the contact regions you can see over here. So automatically we can see that there are almost 30 contact regions that are there, or 38, it is 29. You have somewhere around 29 contact regions. Now where exactly are these contact regions defined? So if you click on contact region, you will see that in details of the contact region you will see where exactly is that contact defined. So now you can see that this contact is between valve cover bolt and the valve housing. So if you see valve cover bolt and valve housing, these are the components. So it is between the valve housing and the bolts. So we have 3 bolts over here. So it is over there. So this contact region is between the bolt and the housing. Then we have contact region 2, which is between the cover bolt and the cover. Then we have contact region 3, which is between the cover bolt and the arm. If you see, this is the contact which is getting defined. So like this you can see all the contacts that are defined automatically. So this is what we are talking about in the PPT, that wherever there is a contact, or wherever there are two geometries that are touching each other, there the contact region will be defined automatically. Now let us understand what are the types of contacts. Now we have already understood that the contacts are defined automatically. Now we will understand the types of contacts. So in the types of contacts, we basically have 5 major types of contacts, that is bonded contact, no separation, frictional, frictionless, and rough. So there are 5 types of contacts, and these contact types are visible over here. If you see, if you select any contact region, in the details window you will see that where exactly is this contact. You will see the part names plus you will see the type. So these are the 5 types of contacts that we are talking about. Okay, now let us understand what is the meaning of each and every contact. So let us talk about the first contact that we have, that is the bonded contact. The bonded constraint is the default contact defined between the surfaces. So this is the default contact which is defined between all the surfaces. Now these, whatever contact regions have come automatically, everywhere you will see that it is a bonded contact. So bonded contact is actually the default contact that gets applied to all the contact surfaces. It can get defined between surfaces, solids, lines, faces, edges. It behaves like a glue contact where the two surfaces are not allowed to slide nor separate. So wherever there is a bonded contact, the surfaces act as if they are glued to each other, and there is no sliding allowed nor there is any separation between them. For example, if you have two surfaces between which this contact is defined, what happens is they are not allowed to slide nor they will separate from each other. If you take an example, suppose if you have two plates between which there are gaps, or if there is penetration between the two plates. Now if I want that these two plates should not move with respect to each other, you can assign a bonded contact. So even if there is a gap, there is a visual gap between the two plates, but still I want to say that these two plates should not move about each other, you can apply a bonded contact over there. So that means even if the plates don't touch each other, and still I want to say that they are not going to move nor slide, you can assign a bonded contact. Similarly, if there are two plates which are intersecting or penetrating with each other, but still I want to say that there is no sliding, no separation, I can directly say that it is a bonded contact. Okay, so that is nothing but a bonded contact. Next, we will talk about no separation. The no separation contact is similar to the bonded contact, where the two surfaces can slide a little but they cannot separate. Please understand, these two surfaces, wherever you have given a no separation contact, they can slide very little with respect to each other, but they cannot separate from each other. You can use this contact when you are very sure that the load applied to these plates would always be in such a manner that these surfaces will not separate. That means when can we use this no separation contact is if there are two plates and I am applying some load on them. If I am very sure that that load that I have applied will not cause any separation between the two plates, there I can very clearly use no separation contact. And in this contact we are saying that there is very little sliding allowed. So the sliding allowed in this contact is frictionless, but the sliding is very limited. It is a very limited sliding that we get in no separation. Okay, after that we will move to the next contact, which is frictional contact. Now in this contact type, the two contacting geometries can carry shear stresses up to a certain magnitude across their interface before they start sliding. This behavior is called as sticking. So if we talk in simple words, the surfaces that are allowed to slide by a user-defined value of coefficient of friction is mu. So if there is some user-defined value, if you want to allow the sliding by some user-defined value of coefficient of friction, you can use a frictional contact. This is like a real-time condition where two surfaces slide against each other, and the sliding will always occur after the resistance value of mu is achieved. So once if you say that the frictional coefficient is 0.5, the sliding will occur after the 0.5 resistance is achieved. Okay, and this will always give us the real-time effects. It will be like a real condition where two surfaces are sliding against each other. Okay. Next contact is frictionless. This setting models standard unilateral contact, that is normal pressure equals to 0 if separation occurs. That means surfaces are allowed to slide freely where the coefficient of friction, that is mu, is 0. So in frictional contact you can give some user defined value for mu, but if you consider frictionless, the surfaces are sliding against each other, but it is free sliding, and the mu, that is the coefficient of friction, is 0, and the contact can open and close depending on the loading condition. That means if you have applied a frictionless contact between the two plates, and if the load applied on the two plates can cause some separation, they will separate. If the load can cause some sliding, it will slide. Okay, thus in this condition or in this type of contact, even gaps can occur over here. That means on two surfaces, on whatever two surfaces you are applying a frictionless contact, there gaps can also occur. And this type of contact is generally used while performing non-linear analysis. Please understand, this is generally used when we are performing non-linear analysis. And the last type of contact is rough contact. This contact is similar to frictionless setting, and it models a perfectly rough frictional contact where there is no sliding. But here what happens is the surfaces that are allowed to separate, even if you are saying that there is no sliding, the surfaces can separate from each other. That means in this contact, the coefficient of friction that we consider is generally infinite. That means mu is equal to infinite. It can be infinite. So these are the types of contacts that we have in Ansys Workbench. Okay. So I'll repeat it once again. Rough contact is a contact where it is a rough frictional contact where there is no sliding, but the surfaces are allowed to separate depending on the loading. Okay, that means if the load applied is going to cause some separation, the separation will occur, but it will not slide against each other, and the friction coefficient of friction, that is mu, is considered to be infinite in this type of contact. Okay, so these are the types of contacts that we have, that is bonded, no separation, frictional, frictionless, and rough contact. Okay, now let us understand how to apply these contacts in Ansys Workbench. So this is the software where we have already imported the assembly. Okay, we have already understood that why renaming of components is necessary. Okay, and we have also seen the contacts that has been defined. So according to the PPT that we saw earlier, the bonded contact is the default type of contact that you will have in all the contacts. So if I see all the contact region, you will see that the type is set to bonded. Okay, now we have a bolt over here. Okay, the contact is between, the first contact is between the bolt and the housing. Okay, so what is the type of movement that you want to allow over here? Is it going to be bonded, or you want to use some other contact? Can be selected from here. So now here I can change according to the condition. Okay, now let us say, okay, we have one, this is the arm, the valve arm over here. Okay, and then we have the valve cover. Okay, now in this condition between the cover and the arm, I want to say that there is going to be some frictional motion between them. Okay, when this arm moves, there will be some frictional motion. Now if I want that frictional motion to be applied, I need to first find that contact. So you need to see the contact between the cover and the arm. So contact region number 21 is between the cover and the arm, and here I want the type to change to frictional. When I say that it is a frictional contact, you can give the value of mu, that is the friction coefficient, and here I will say that the friction coefficient is 0.6. okay, so now here this contact will act like a real-time condition where there will be some frictional motion between the two. That means they are allowed to slide against each other, and the mu value is 0.6. Similarly, I can give or I can define the other contacts also. Now if you look at the assembly very closely, okay, in all the conditions, if you see that the cover and the body, the valve housing and the cover, okay, in this two again it is going to be a bonded contact, means they are not going to slide against each other, neither they are going to separate from each other. So I can directly say it is a bonded contact. Okay, now there is only one condition where the arm is going to rotate over here, because of which there will be some frictional motion over here, which I have already changed in contact region number 21. As soon as you change any contact region, for example, if we see okay, now let us say that contact region number 18, which is between the shaft nut and the shaft nut and the shaft. So this is my shaft and we have the shaft nut over here. Okay, so between this shaft nut and the shaft, okay, I will say that it is going to be a no separation. So the type of contact is no separation. That means the sliding will be there, they can slide against each other, but the sliding is going to be very limited and there will be no separation. That means even if the loading is in such a manner that it cannot separate from each other. Okay, so as soon as you change, you will see that it has changed. Okay, wherever you make changes, you will see what type of a change you have made over here. Okay, now in some conditions I can say, now for example, contact region number 14, which is between the valve shaft and the valve. Okay, so valve shaft is this. Okay, we have a valve shaft inside over here and we have the valve. So this is that plate over here. So between these two, I will say, that is contact region number 14, I will say that it is a frictionless contact. So as we discussed earlier in the PPT, that frictionless contact, in this type of contact what happens is they are allowed to slide freely, where mu, that means the friction coefficient, is considered to be 0. So this contact can open and close. If the load applied in this condition, if it is going to cause some separation, the separation will be caused. If it is going to cause some sliding, it will cause the sliding, but sliding is going to be very free. Okay, so like this, according to your assembly, according to the condition, you can apply the contacts in the assembly, and then after the contacts have been defined, you can assign the boundary conditions like the forces, pressure, degrees of freedom, and we can solve the assembly, or we can solve the problem. Okay, so this is how you will assign the contacts. Now in some conditions, as we discussed, for example, if it is a bonded contact, okay, in bonded contact we discussed that even if there is a gap between the two parts, and if I say that I don't want the two parts to move, even there you can assign a bonded contact. So now if the parts are separate from each other, for example, if you look at a surface, okay, now see, okay, now these surfaces are actually in the same part, we cannot talk about, okay, for example, okay, look at this condition. There is one surface over here and there is one surface over here. Now this is the nut and this is the arm. Okay, so now there is no contact between the two. Because they are separate, there is no contact. So the contact does not come automatically. But now if there is some motion that is happening between the two, okay, and I want to block them, then you can define a contact over there. Please remember, if the bodies are separate from each other, the contact will not come. And now if there is any relative motion between the two and I want to block that, I can use a bonded contact for that. So in that condition, you can define a manual contact. Now here what we have seen is the contacts have come automatically. But if I want to assign any manual contact, you can come over here to the Contacts tab, right click on it, say Insert, and go to Manual Contact. The contact will be defined, and then you can select the surfaces between the two parts. Okay, as soon as you select the surfaces, you will see that the bodies are defined, and then you can define the nature of the problem, and I will say it is going to be bonded. Okay, so this is how you can assign manual contacts also if the contacts have not come automatically. Okay, fine. So this is how we will assign contacts in mechanical window if we are working on assemblies.